Hello again in another video. So in the last video we seen how to we decided to talk about the determinant of a matrix. We know what the determinant is from our previous videos. We know the determinant for a 2 by 2 matrix is actually 3 multiplied by 6 minus 8 multiplied by 4. So when we have this cross, we multiply 1 and subtract it to the multiplication of the other. Anyway, that's the determinant of a matrix. We've also seen that the inverse of a matrix can be obtained using several methods, one of which is by multiplying. If it's a 2 by 2 matrix, we get the determinant and we do the cross thing. We flip the we flip to like in this example, we flip the 3 and 6 and change the signs on 8 and 4. Now, another thing to also remember about inverses is that we could multiply it if it's more than 2 by 2. Even for a 2 by 2, you can multiply it by the identity matrix and solve accordingly using the Gauss-Jordan elimination or the raw elementary functions to obtain the inverse of the function. Now, our goal is to have an identity matrix, and the identity matrix will automatically be converted to the inverse. Now, that's another method. Now, the third method, which we decided not to dive into much, but we were acquainted with, which is called the minus cofactor and conjugate. So conjugate, yeah. So basically what that is saying is that you would want to take the so you would start off with the minor function, which is the most important bit, and so you take on one element and you ignore everything on that row and column and take everything else, and then the same, and then you move on to the next element and so on and so forth. Now what you are going to do is that once you have, and then you would want to calculate the determinant and multiply it by each of the so you would calculate the determinants of each of the rest of the elements. So it requires a bit of calculation, which we really didn't think of much of. Like in this case, we take on the element and then we get the determinant of each of the rest. Now, like in this case, we get the determinant of this bunch and then this bunch and then the other bunch and so on and so forth. After we get the determinant of the minus, we get the cofactors, and the cofactors is basically a checkboard change of sign thing. Cofactors is change of sign checkboard, and then the very last step is but you just transpose and, which is the educate, and then the very last step is that you multiply the original, you calculate the determinant of the original matrix, which is this one, and you multiply it by whatever we've obtained through these steps. And that's about it. You see, it's pretty hectic, especially when the matrix can grow pretty large. Now, one thing we decided to talk about in this video is calculation of determinants. We will be discussing that in this video. We've already done we've already calculated the determinants, so we could calculate the determinant here. We've already done I don't think we should spend more time on do things a bit differently. So let's explore what the determinant of a matrix is all about. The determinant of a matrix is a special number that can be calculated from a square matrix. A square matrix. Interesting. So that's not number one. Matrix in array of numbers that we know of. The determinant of the matrix, the calculations are explained later. So 3 multiplied by 6 minus 8 multiplied by 4. So what is it for? The determinant tells us things about the matrix that are useful in systems of linear equations. So the determinant helps us to find the inverse of the matrix that we've seen, and it's also useful in systems of linear equations. This is not... Oh yeah, we actually can... Do we? Yeah, solve linear equations when you have ax equals b. Then you would get the inverse of a, and then you multiply it by beta as well to get to leave the x on the x matrix on its own, which is the variables. Got that. The symbol for determinant is two vertical lines. Okay. I think we should have that sign, and then yeah, so it has the same sign as that. Calculating the determinant. So first of all, the matrix must be square. This is really crucial. We have to stress on this square matrix. The same number of rows as columns. Then it is just basic arithmetics. Here is how. So for 2 by 2, 2 rows, 2 columns, the determinant is a multiplied by d minus b and c. Yeah, now we know b is positive, red is negative. Nice. Do we have how to calculate it? Yeah, it's already there. For a 3 by 3 matrix, things are a bit... So 3 by 3 is still square. Yeah, I'm gonna add this too. It's a nice way to yeah, I think so this is the determinant. I think it's best to... I think I should organize this to have like sub pages. Like you can just click on whatever, and then you alright, straightforward. So we have 3 rows and 3 columns. Determinant. So A, EI minus FH, B would be DI, FJ. So you basically Should return it to another page. Just like there's a lot of topics covered for a single matrix. Well, it's important to know all of them, I believe, because we need to do the inverse and other operations on them. So for C, we eliminate this and this would be left with this. Multiply A by the determinant of the two. It's not in A's row column. Likewise for B and C. Sum them up, but remember the minus in front of the B. We should highlight it too. As a formula, remember the vertical bars mean determinant of, so A multiplied by determinant of A minus B, and so on. So this is an example where we have 6, 1, so let's take 6, ignore, so it's minus 2 by 7 minus 5 by 8 minus, it's 4 by 7 minus 5 by 2 plus 4 by 8 plus 4. Well, let's see what's the deal with 4 by 4 matrix. Oh my god, looks interesting. This looks like it's a multi-level Laplace. There's a multi-level way to do it too. Let's see, so for 4 by 4 matrices and higher, the pattern continues for 4 by 4 matrices. Plus A times the determinant of the matrix that's not in A's rows or column. Okay. Minus B that is not in B's rows or column, plus C times the determinant that's not in C's column minus D. So the sign is interchangeable as a formula. But how would you calculate this? Would you like take another, so A, F, G, A, H, yeah, that one we understand. Minus, plus, minus, this that we understand. Notice the pattern is important to remember. The pattern continues for 4 by 5 matrices. So the determinant of the three functions, like the determinant, so you would do and then you would, oh okay, so you would get the determinant of this, so you consider this as its own matrix, and then you would get the determinant of this using F, you would do the whole magic, K multiplied by P minus L minus O, and then you would do the rest for the same. Okay. Remember, we still get the determinant of each element. Uh, Multiplied by the minus that 3 by 3 would continue to become value multiplied by 2x2, as we have seen. Hierarchy. Hierarchy. Pretty terrible. Sometimes I do not remember the spellings of things. Whatever. Anyway, so in that case, it's very important to notice the signs. And then let's try red pen, blue pen. Let's go for green. Customize. Lime. Okay. So this method of calculation is called the Laplace expansion, and I like it because the pattern is easy to remember. But there are other methods, just Laplace expansion. Laplace expansion. Laplace, I think, is a French word for this place. The place, I think, you expand from whatever it is that you have, so you expand it in place. I think that's what this is all about. Anyways, it's interesting how there are different ways to manipulate the matrix and matrices. just to get the inverses and to solve, because the matrix being the basis of linear equations. I mean, I couldn't imagine myself solving linear equations of three variables or more using substitution and elimination, so it's easier to just opt for matrices. And I've also seen how to solve different variables using identity matrix, which is really powerful way of solving linear equation problems. And let's have another video where we do exercises on we need to do a little bit of some exercises on determinant matrix. I'll get me a pen and paper, and I will see you in the next video with the questions on Laplace expansion. I just hope the questions don't expand to grow really huge. I mean, no amount of paper would be enough, and we are all about being green.